Perihelion is behind us now. In the last day, reports confirmed that 3I Atlas reached its closest point to the Sun, at roughly 1 2/5 the Earth-Sun distance, almost buried in solar glare from our line of sight. That glare is why backyard observers never had a dramatic moment at the exact time of closest approach. The science didn't need a spectacle. What matters after the turn is how the coma and tails respond to the heat, whether the light breathes smoothly or in short bursts, and what space-based eyes recorded while we were looking past the sun's brilliant edge. First, the safety piece stays exactly where it has been for weeks. 3I Atlas is on a hyperbolic one-pass trajectory. That simply means it came from outside our solar system. It looped around the sun at a safe distance, and it is headed back out again. There is no credible scenario in which it bends toward Earth. Our nearest Earth distance remains very large, farther than the sun is from us. With the peace of mind settled, we can give our attention to the actual physics, how gas and dust behave in sunlight, how the solar wind pulls a straight plasma tail away from the sun, and how geometry, our viewing angle, can make some features look unusual even when they're perfectly natural. Now, about those last 12 to 24 hours headlines you've been seeing. The theme is consistent across professional outlets. Perihelion timing, late on the 29th into the 30th, a universal time, poor visibility from Earth at that moment because the comet sat too close to the sun in our sky, and a handoff to spacecraft and deep imaging facilities with better angles. Think of it like trying to admire a candle flame while someone shines a flashlight directly at you. You step aside first, then the details appear. That step aside, for Earth observers, happens over the next several mornings as 3I Atlas slides into the pre-dawn sky at a safer angular distance from the sun. It will still be faint at first, but faint is fine. Faint is where honest measurements live. Spacecraft gave us a crucial before picture earlier in October, when the comet passed near Mars. European missions at Mars turned their cameras and instruments toward this visitor and captured modest but clean detections. A moving point with a soft halo, tracked precisely where the ephemeris predicted. Those Mars-side snapshots matter now because they give us a baseline. Post-perihelion behavior, brightness, color, tail shape, can be compared directly with that baseline, and the differences become the story. Steady outgassing versus brief jets, dust-heavy versus gas-rich, smooth coma versus structured strands. Science is comparison. Perihelion simply marked the moment when the after column begins to fill. One detail that returned in recent coverage, and confused some viewers, is the talk of a sunward jet. A jet is a narrow stream of gas and dust from a vent on the nucleus. As the nucleus rotates, the jet's direction changes. Freeze that motion at the right moment and, yes, a strand can appear to point toward the sun. It's not breaking the rules of comets. It's geometry plus timing. In the days after perihelion, observers will watch whether that kind of strand sharpens, fades, or breaks into moving knots. Tracking a knot as it drifts outward lets us calculate how strongly sunlight pushes dust. Larger grains lumber, finer grains race. That's how we turn a blurry line into a measurement you can print on a chart and argue about in a friendly way. The best way to understand post-perihelion science without jargon is to hold 3 keys in your pocket: brightness, color, and shape. Brightness is breath. If the light rises gently and settles gently, the comet is breathing evenly. If it jumps, rests, then jumps again. A specific vent may be opening as the nucleus turns. Color is composition. Slightly redder light usually means dust dominates the glow. Slightly bluer means gas lines are singing in sunlight. Shape is weather. A straight, narrow plasma tail points away from the sun like a ruler, evidence of the solar wind's grip, while the dust tail often curves, telling you about grain size and how much sunlight is pushing. With those 3 keys, you can read most of the updates this week in plain language. Another phrase you'll hear after perihelion is anti-tail. It looks like a thin line angled roughly sunward. That sounds wrong until you remember perspective. In edge-on geometry, larger dust grains, less bullied by sunlight, tend to linger along the comet's orbital path. Seen from the right angle, that trail can look like a pencil line toward the sun. It's a breadcrumb trail, not a special effect. If early November mornings give us that edge-on view, imagers may catch an anti-tail. If they do, it's not an omen. It's a clue about grain sizes. Grain sizes point back to surface texture. Crumbly crusts shed bigger bits. Tighter crusts favor fine dust. That's valuable regardless of how dramatic the picture looks on social media. Let's translate plasma tail too, because it will appear in the next round of reports. The coma is mostly neutral gas and dust, but a fraction of the gas gets ionized, electrically charged by sunlight. The solar wind, which is a fast flow of charged particles from the sun, grabs those ions and drags them straight away from the sun. That creates a narrow, often bluish tail. It acts like a windsock for space weather. A clean straight line suggests a steady wind. Kinks or sudden bends can mean the wind's magnetic field shifted or snapped, briefly disconnecting the tail before it reforms. None of this implies danger. It's weather in space. The more mornings we can watch the plasma tail rebuild and stretch after perihelion, the better we can tell what the sun's wind was doing during this passage. A separate thread in the last day's updates is water behavior. Teams using space telescopes reported hydroxyl OH, a child of water that forms when sunlight breaks water apart. Detecting OH is a reliable way to say water is present, even when Earth's atmosphere blocks the direct ultraviolet line. What mattered here was where and when that signal showed up, surprisingly far from the sun earlier this month, when many comets are still quiet. That suggests a surface that exposes fresh ice efficiently, maybe because it's porous, or because tiny fragments break off and release water as they go. That farther out than usual activity is part of why 3I Atlas is interesting. Oumuamua looked dry. Borisov was rich in carbon monoxide. Atlas is showing water behavior early and often. 3 visitors, 3 different notes. That diversity is the lesson. How do we know if perihelion changed anything? That's the right question for today. The answer arrives in small, testable ways. Does the inner coma look a touch bluer in specific filters, hinting that gas lines brightened after the hot pass? Do short time scale, light curve bumps repeat, betraying the nucleus rotation and the schedule of its vents? Does the dust tail's edge sharpen, suggesting coarser grains, or soften, suggesting finer dust? Are there signs of an anti-tail forming as geometry improves? Each of those is a practical kitchen table check. Some will show up in amateur images, others will emerge from professional spectra that take a few days to process. None require magical thinking. They rely on doing yesterday and today the same honest way, and then comparing. If you're wondering why so many outlets stressed you won't see it at perihelion, here's the simple geometry again. The comet's angle from the sun in our sky, its elongation, was too small for us to look safely or effectively. That was never a conspiracy. It was the plan, set by the solar system's clock. As 3I Atlas glides away from the sun's direction, pre-dawn observing windows open. The view will be low in the east at first, then slowly higher. Expect a faint target, roughly magnitude 11 to 12 to start. Camera and telescope territory. That may sound modest if you were hoping for a great comet, but it's the normal look for a distant, interstellar visitor. Brightness is not the measure of importance. Repeatable measurements are. Color is another friendly teacher, and it's showing up in analyses again today. Dust that soaks heat and shines tends to give the coma a warmer tint. Gas lines excited by sunlight lean cooler, slightly bluer in specific filters. A simple gradient from the inner coma outward can tell the day's story. Gas singing near the heart, dust glowing farther out, or vice versa. That gradient is like rings in a tree. Not exact ages, but honest hints of what woke first and what lingered after the local sunset on the nucleus. A single sentence like, "The gas sang near the center while the dust thinned outward," is more useful than a wall of codes. It lets anyone reading tomorrow's update say, "Oh, it changed," or "No, it held." That's science at a human scale. Yai polarization, a measure of how light lines up when it scatters off dust, may also be mentioned in the coming days. It sounds fancy, but you already know the feeling. It's the way polarized sunglasses cut glare and reveal detail. In comet terms, more or less polarization at certain angles tells us whether grains are fluffy like soot or compact like chalk. Fluffy grains darken and heat faster, then drift farther. Compact grains stick close to the track and help draw that thin, anti-tail pencil, if the geometry is right. A polarization curve paired with a color red gives you texture, not just outline. Texture is what hands can grip. Let's pull back for one paragraph and remember why this particular object is such a compelling teacher. It's interstellar. That single word means the ices, dust, and tiny rocks inside 3I Atlas were shaped around another star long ago. When those materials lift into sunlight near our sun, we're tasting a different kitchen. Oumuamua, Borisov, and now Atlas. 3 recipes, 3 flavors. In the last day of coverage, the short list of what matters was the same across outlets. Safe distance, post-perihelion behavior, water-related signals detected before perihelion by space telescopes, and a visually modest but scientifically rich reappearance into our pre-dawn sky. The excitement here is not a sky show. It's the chance to add a clean page to the book of small bodies born under other suns. What should you watch for tonight and tomorrow morning? If you have a modest telescope or a camera, start simple. Short exposures to freeze any fine structure in the dust tail. Longer exposures, stacked gently, to tease out a faint plasma tail and color in the coma. Jot times. Note air steadiness. On the second morning, compare. A knot that moved gives you a speed. A speed hints at grain size. Grain size hints at the toughness of the crust. If you see talk of a disconnection event, it's the plasma tail reacting to a change in the solar wind, an honest space weather blip. If someone posts an anti-tail, read for the viewing geometry. These are small, testable claims. They either hold when repeated, or they fade. Repetition is the referee. Media literacy belongs here too, because the last day brought a flood of thumbnails and emphatic titles. When you hear panic, translate to high interest. When you see mystery object, translate to interstellar comet confirmed by orbit. When someone says they're hiding images, ask, politely, for the data release schedule. Spacecraft data go through calibration and checks. That lag is not a cover-up, it's how instruments earn trust. A crisp spectrum that comes a few days late is still fresh where it counts, and it teaches more than a fast rumor ever will. A practical note for families. This is a perfect week to do one small kitchen experiment that puts comet physics into fingertips. Put a little flour and a few rice grains on a dark tray. Blow gently across. The flour, the fine dust, lifts and arcs away. The rice, the larger grains, barely budges and hangs closer to the line. That's the dust tail and the anti-tail in 10 seconds. Now, warm one corner of the tray with a lamp for a minute and repeat. More flour lifts. You just explained coma growth after heating. A child can own that idea, so can a grandparent. That's the kind of learning this comet is giving us. Nothing to fear, plenty to notice. So, where does the story go from here? In the next week, the comet's angle from the sun improves for morning observers. The best images will still come from instruments with sensitivity and stability, but patient amateurs will contribute crucial comparisons, especially those who can image on consecutive mornings with consistent settings. Professional teams will release spectra and refine light curves that test 2 ideas most. Did perihelion open new vents? And did the balance between gas and dust shift? A third theme, non-gravitational nudges, will likely get a quiet update as more precise positions come in. None of this needs capital letters. It needs care. Perihelion days are like opening a kiln. You don't stare into the hottest moment for long. You study the pieces when they come out and cool. That is where we are now with 3I Atlas. The exact closest approach to the sun happened in glare, which was expected. So the meaningful work in the last 24 hours has been about what the coma and tails look like as the geometry improves. Observers reported the same overall pattern. The comet remains faint, safely far, and scientifically cooperative. Cooperative means this. Features are subtle but there to be measured. Brightness is steady enough to compare night to night. And the tail system is rebuilding in a way that lets us read space weather without drama. That is a good outcome after the turn. I want you to have a feel for the 3 simple clocks people are watching this week. The first is the spin clock, the nucleus rotating, sometimes betraying itself through small, repeating bumps in the light curve when a jet comes around into sunlight again. The second is the heating-cooling clock, the way the coma brightens and softens as the day side warms and the night side cools, even on a tiny world with no atmosphere to hold heat. The third is the solar wind clock, gusts, lulls, and directional shifts that tug on the plasma tail, straightening it like a flag, or putting a kink in it like a sudden eddy. These clocks don't tick loudly, they whisper. But if you listen over a few mornings, you'll hear the rhythm. Another thing you'll see in the most careful updates is a preference for comparisons over claims. Compared with the Mars-side snapshots earlier in October, the coma is slightly more extended. Compared with the night before perihelion, the color near the nucleus is a touch cooler in the narrow filters that listen for gas. That kind of language can sound dull to a headline, but it's the language you can trust a month later. It also helps ordinary viewers feel at home in the subject. You don't need a degree to understand a little more and a little less. You need patience and the habit of looking twice. Let's talk about the possibility of fragments for a moment, because people naturally ask, if a fragile crust cracked under heating, we might expect to see a temporary rise in brightness, a thickening of the inner coma, and perhaps tiny off-center clumps that drift outward and fade. None of those is guaranteed, and all of them are measurable. In the last day, the tone has been cautious and responsible. Look for repeating signs, do not overinterpret a single frame, and wait for independent confirmations. That restraint is a mark of good practice in this kind of work. It protects the audience from whiplash and protects the science from rushing down a dead end. There's a kindness in the geometry that is unfolding now. As the elongation increases, meaning the comet's angle from the sun in our sky grows, it becomes safer and easier to separate the glow of the coma from the background. You'll hear the word air mass from some observers. That is simply a way of saying how much Earth's atmosphere you're looking through. Low in the dawn, the air mass is high, and the image is compromised. A few degrees higher in the sky, and the scene improves sharply. The best amateurs know this and plan their sessions to catch those short, better windows. That kind of planning matters more for a faint object than for a bright one. Faint targets repay you by keeping you honest about your method. If you are curious about how professionals separate dust from gas without a physical sample, here's a short, friendly explanation. Dust shines by reflected sunlight. Gas glows because sunlight gives it energy to emit light at very specific colors. Instruments use filters, thin pieces of glass that allow only a narrow color to pass, to isolate those signatures. If a filtered image that listens to a certain gas brightens near the nucleus while the dust filter stays the same, the team knows that gas became more prominent. That's why you'll see carefully annotated images with terms like continuum, dust, and emission. Gas. The labels may sound technical, but the idea is simple. One picture shows reflected light, another shows the gas singing. We should also translate polarization into everyday senses again, because updates may mention it as the comet rises to more favorable angles. Polarization is a fancy way of saying that light waves get lined up when they bounce off certain surfaces. Polarized sunglasses use that trick to cut glare from water or pavement. In a comet's coma, how strongly the light is polarized at specific angles can tell you whether the grains are fluffy or compact, rough or smooth. Fluffy grains are like soot. They heat quickly and go farther. Compact grains are like tiny chalk pebbles. They tend to stay near the track and sketch that pencil-thin anti-tail when the view is edge-on. A good polarization curve, paired with color and brightness trends, gives you a three-dimensional feel for the dust without ever touching it. Now, let's acknowledge the human side of the coverage in the past day. There were big titles and strong thumbnails leading into the 29th. That is how the online world works. But after the date on the calendar was crossed, the best voices did a useful thing. They lowered the temperature and shifted to the measured parts of the story: safe distance, expected faintness, early water-related detections, and what the next mornings might show. That pivot is healthy. It models to the audience that science can be exciting without crisis, that curiosity lives just fine in a calm room, and that we don't have to treat every cosmic event as a cliff edge to care about it. If you are introducing a young person to this subject, that tone might be the most valuable lesson of the week. Some viewers asked why Interstellar doesn't automatically equal bright or dramatic. The reason is that brightness depends on size, composition, distance, and how efficiently sunlight can lift dust and gas. Oumuamua was small and odd, no coma at all that we could see. Borisov was more like a classic comet and showed well in amateur telescopes. 3I Atlas is teaching in a quieter register, active enough to measure, faint enough to require method. 3 travelers, 3 personalities. In that variety is a promise. Each future visitor will carry a different mix of ices and dust from its home system. Across the years, those differences will outline the diversity of other solar systems, even before we scoop up a sample. For observers who want to contribute in the next week, the advice circulating today remains practical. Aim for consistency over heroics. Use the same exposure settings on consecutive mornings if you can. Frame a tight crop of the coma for color comparison and a wider field for tail structure. Write down the times to the minute. Note the seeing, the steadiness of the air, because a sharp rise in blur can masquerade as a thicker coma. If you process the images, keep a light hand and note exactly what you did, so others can replicate it. That word, replicate, is the soul of this work. It turns one person's pretty picture into a community's shared measurement. On the professional side, the pipeline now is equal parts careful and routine. Raw data collected near Perihelion are being calibrated, instrument quirks removed, background corrected, timing verified. Spectra will be stacked to increase signal and isolate lines that belong to particular molecules. Once those lines are confirmed, the team can compare with earlier spectra taken before perihelion. A jump might mean a new vent. A drop might mean a shallow layer exhausted itself at the hot pass. Either way, nobody has to guess. The numbers will point. The trick is resisting the temptation to declare a winner before the analysis is finished. In the last day, the grown-up voices did resist, and that bodes well for clear communication. I also want to cover a small but important phrase. Elongation improves. In plain speech, that means the comet moves away from the sun's position in our sky, making it easier to see. Pre-dawn elongation improving is like shifting your chair away from a bright window so you can finally see the person across the table. You will see observers use degrees to describe this. 15 degrees, 20 degrees. Think of a clenched fist at arm's length. That's roughly 10 degrees. When the comet is 2 fists from the sun in the dawn sky, you're in a much better place to pick out the delicate tails. Until then, patience saves wasted sleep and keeps expectation in a healthy range. I'll bring this extended update toward a close with the same steady posture. After October 29th, the narrative is about patience, not panic, measurement, not mystery, and safe distance, not speculation. The comet did what the model said it would do. We are now at the part of the story where small, repeatable details matter most. A gentle rise in brightness here, a cleaner plasma tail there, a hint of an anti-tail if the edge-on angle cooperates, a light curve bump that may be rotation and speaking under the breath. Each piece is quiet. Together, they are a lesson you can trust. Here is the fresh takeaway, put simply. In the last day, nothing in the credible updates changed the big picture. Perihelion passed as expected. The object remains a distant, safe, interstellar visitor. The immediate future is a set of early morning windows where cameras and telescopes can watch the coma and tales speak in finer detail now that the glare is easing. That is the honest shape of the news, and it is enough. Because in that plain shape, we get to understand how a world from another sun reacts to ours. And we get to practice the kind of attention that makes all science possible. And one more practical viewing note for your pocket. Over the next several dawns, aim low in the east. Give the comet 10 degrees of altitude before you start long exposures, and keep your settings the same from one morning to the next. The differences you'll see on your screen will be small, but they are the story.